Hello everyone and welcome to exciting video, at least definitely for me, because us here at Vulcan Alpha we specialize in bespoke engineering solutions aimed at aerodynamics. So we make model specific wings and splitters, we make some top secret stuff, and sometimes, like today, we make something in between that is really specific for a client, really extreme, but we are definitely extreme, but we are able to talk about. And if you would have told me 10 or 15 years ago that one day I would have a company that makes something for twin turbo Lamborghini Huracan, I would have peed in my pants from excitement. Yes. So here's what we have that we will nerd you out today about, all the specific and features about our latest bespoke DRS design products, or the DRS wing for that can be mounted actually pretty much anywhere, but in this case we will show you how it was designed for Huracan with lots and lots of horsepower. And while we're standing here, because we did some videos of this and well, for internal content also for the client and also for ourselves, I want to say it looks epic because we actually set up this area, which is our little warehouse here. So big shout out to Big Box for setting this all up, because now it looks like we're getting somewhere. We're still in setting up our workshap, but anyway, we're getting sidetracked. Squirrel, squirrel,
100 tires.
Squirrel. Anyway, let's focus on the main thing. So, Lapo, walk us through the coolest features, you as an engineer and designer. Mm-hmm. Yes.
So, where do we start?
We'll start with the main question. How much downforce does it make?
As always, it depends.
Yes.
It depends.
What was the technical, let's say, requirement by the client?
We got an email from the special client who told us, well, I have this twin turbo Huracan, I have problems at different speeds with different, let's say, scenarios. So at low speed he has not enough grip, and at high speed he has stability problems, and he currently have a single element fixed wing, and so he wants the benefit of both worlds. Mm-hmm. So we already have developed a DRS system which is universal, let's call it. And so, but he wanted something more specific, so we designed a whole upright system to work with his specifications. More importantly, he gave us the width of the overall wing, what's his plans in terms of top speed and power. With that, I can then calculate I can put the wing in the perfect position to then be able to satisfy his own needs. In this case, we wanted maximum drag reduction at high speeds, so the secondary element is a bit tweaked in position than the original DRS system. When fully opened, it will technically delete almost 60 to 80% of load. It depends on how the rake of the car and then the diffuser section, but it should technically delete, let's say, 65% of load from the rear. So low to medium speed, you're going to have the full load of the aero system, and then at high speed, you're still going to have the aided stability from the big end plates and the main element, but then you're not going to have all the drag penalties of the second element that then interacts with the lower element.
Because indeed, sorry for interrupting you, it looks a lot more extreme when it's open compared to the other designs that we do, because this was specifically made for drag racing applications.
Yes.
So it's not really track car, but you can of course go on track, but the main feature was here to actually open up the wing as much as possible for the top speed runs. Nice, because usually like when you open DRS, the reduction is less than 50%, right? It depends again, of course.
It depends on everything, but usually you're aiming for that 40 to 50% drag reduction. In this case, I'm aiming for a higher reduction system. That said, for example, if you're looking on a circuit car, you definitely need a bit more load, even with the full DRS open. So.
All right.
Everything though, I want to add, it's been redesigned for the application. So if you compare for example, the main beam support for the second element, it's way beefier than the original design. Not because the original design is not capable, because it's already on, let's say, a pretty powerful car that has 600-700 horsepower, the M4 in Australia, for example. But because in this application, the car is going to go 350, maybe 400 kilometers an hour, depends on the real top speed. Because I think he's going to run it in the mile on 2 miles.
Texas mile, probably.
Yeah, so 230, 250 miles per hour, it's definitely doable. So I want everything to be as, let's say, rigid and strong as possible. So for example, the end plates, although you don't see it here, yeah, well, you can maybe see it here in the slot. It has internal ribs, so it's an aluminum CNC aluminum plate that goes sandwiched in the actual end plate. This kit keeps all the position locked up and keeps the end plate super lightweight. So basically the skin is not structural, the inside, let's say, skeleton it is. Furthermore, I've added this slot here. Basically this takes the load from the wing itself, and it takes it off the, let's say, the main action system, and it puts it again on the end plate, and this adds support. Because you really need rigidity and support at high and low speeds for this application, because, for example, the acceleration force is a lot. You need lots of support. So in this case we have 2 main pivot points, 2 side main pivot points, 2 lateral guides with a load point, and then the main actuation, which is all, for example, the different lead from the old design. These are 8mm in diameter. Also the main, let's say, we're still in the shipping process, so nothing is finalized, but these are 8mm instead of 6mm, so everything is beefed up for the application. Again, I like double shear process because it takes the load that spreads it evenly between the 2 sides, so everything is double shear. And I also try to minimize the weight. So for example, we changed the design now. All of our DRS system have, for example, for covering the cables, they have a carbon insert. Then because we're trying to reduce drag as much as possible, I made these 2 carbon covers. Then when the DRS is completely activated, the silhouette completely closes up and encapsulates all the, let's say, mechanisms. So everything is as streamlined as possible.
So look at that.
These are 12-point, really high tensile strength M6 bolts, and they are as good as you can get.
Yeah, yeah. Really,
so
really.
yeah.
Nice.
Yeah,
nice.
Everything is streamlined. For example, a different design than others that I might do is it has a quite rounded front leading edge and a very sharp trailing edge.
Okay.
So this will minimize disruption of flow as much as possible, of course, for the to obtain that high drag reduction. Let's say value that we got.
Yeah.
So
again, this is chassis mounted application because the client said he has a fabricator himself, well, available that will make a proper chassis mount to the actual chassis of the car.
Yeah, he's made some flanges to bolt up to the wing, so I gave him some height adjustment. But then he's gonna create his own.
Because this is not something you want to mount on the trunk.
No, definitely
no,
not.
no, no. Did we mention the actual downforce numbers? We only said about opening and half and everything.
So, the actual figures are around, again, it's not super high downforce wing, so you're looking around 650 mark, 700 max.
At?
Above 300.
Above 300,
and
yeah.
Then I didn't even test it about 400 because it was...
and that's when it's closed.
That's when it's closed. And then when you have the opening system, you should see, again, depends on the situation, so that's the 80%. I'm probably aiming for the 65 to 67%.
But still, 600 kilos of downforce on the wing alone.
Yes.
The GT3 RS, non-Mantai racing car, at 280 kilometers per hour is making 840 kilos over a whole car. Yeah. And this is 600 on the wing alone.
But you already see how
of course.
big it is.
Of course, of course.
The section of the wing is important. The body flow around the car is important. And also, you need to understand that this is also a safety device.
Yes.
Because when you are 300, 400, whatever speed, and you have the DRS open, and then it's fairly common to see the car start pitching. This is, of course, you have your parachute, but this can also help stabilize the car because you can close the DRS system, put loads on the back of the car, and it stabilizes.
Yeah. And now let's mention the operation. If you're tuning in for the first time, all of our DRS systems, well, excuse me, all of our public DRS systems are pneumatic activated, so through air pressure and with the pump that we are supplying, thanks to our partners of MME. They're also responsible for all the... Well,
I'm not going to open.
No, of course, it's for client. Yes.
But this is the all-in-one pump solution that MME created, so you can see it here.
Yeah, they've used this namely for the pedal shift activation of gearboxes.
This is upgraded. So
yes, of course.
This has a bigger reservoir, because
for our application.
Yes.
Yeah, it's custom made, but basically they are known for what they do this, and essentially it's the same system, but with a higher load for our application. And essentially the system by definition is closed, and as a driver you press the button to open it, and then when you release it, it closes again. Of course, you can always program it yourself. The client can always just connect it to ECU, make sure that the wing opens above certain speed, acceleration, parameters and everything, but we always leave that to the client themselves because it's something they need to program for their own application. From our side, it's just open, close, and everything in between the tuner, the client, you name it, can do. I think that's mostly it. Should we have a look at the design, or is there anything else you would like to mention here, actually? Everything is always done in double redundancy, so basically if one piston fails, the other one still will be able to close or open the wing. And go stand in the middle for size.
Does it show the size?
No.
No, does it?
No.
I can put my hand in.
Yeah. I don't know. We need banana for scale because it's pretty big.
Depends on the size of the banana.
That's a very good point. Do we have something more universal here that we can actually show?
Tape measure? I don't know.
Yeah, actually, maybe. Like, yeah, it's quite big. Yeah, massive.
So yeah.
All right, one more thing for scale. Relatively big phone, S25 Ultra.
Or
looks like a baby.
Or you just do this, you know? Just...
I know, but I mean visually it's 17 inch.
Yeah,
Damn.
17.5 inch.
17.5 inch. That's like your wheel size. Yeah. Oh, how long is the width actually? It's basically 5 feet and like 5 feet 2/3. There we go.
I think it's more than that.
No, it is. No, look.
No,
so here's 5. No, here's 5 feet. You see? You got it?
Yeah, I got it.
So this is 5 feet. This is 6 feet. So 5 feet and 2/3.
2/3.
Yeah, it's more than half.
5'10". 5'10". 5'9.5".
All right.
All the guys who are like less than 6 feet. It's 6 feet, guys.
Yeah.
I'm 6 feet.
Yeah. If you're less than 6 feet and you want our wing,
we can call
link in the video description.
We can call a 6 feet wing, which is 5'9".
By the way, everything is of course customizable. This was the size specification of this particular wing that was requested / agreed on, but you can go even wider. I mean, we have a very wide application from a V1 over there. Yeah. Can have a quick look at that before we proceed to the design nerdy part. Well, we have a we have a bottle for scale here. Bottle for scale. There we go. Very good. Yeah, so you can see the main difference is here. It's the covers are aluminum made,
and the whole linkage is almost completely covered.
Yeah.
And the thickness of the
the most expensive bar table in the world. All right, let's go check the. Oh, what's she printing? What's she printing?
Brake ducts.
And here's another very big wing about to be made.
Yep.
Stay tuned.
I'm gonna show you guys the inner stuff that you couldn't see. So for example, this is the ribbing, for example. You would say this is a bit overkill. Yes and no. This is also, let's say, a gluing point for the adhesive, so the two parts are completely adhering properly. So all this area here, for example, that you can see in blue, will be smittered with structural epoxy, and it's going to make a good bond, so everything is connected together. And it's going to support also the main pivot points. Being such a custom project, you could in theory use the carbon as a structural piece with just foam, let's say, and aluminum, let's say, washers, let's say, glued in. Let's call them washers, but it's not fine. But being this custom, I didn't want to have any alignment issues, so this would, let's say, guarantee perfect fitment, and that's what we have because the movement is completely fluid. For example, this is something I really want to introduce back in the automotive world is serviceability and upgradability. So, for example, all these mounts, this is all upgradable. So if he decides to then change it or going for hydraulic, which is something that we maybe are gonna be, let's say, introducing in the future, he can then change the actuation system with a hydraulic system, and the only thing I need to do is make him a new bracket, so he'll have that. And also in terms of serviceability, everything is on bushings. So all the pivot points that are non, let's say, that are actually, sorry, big wear points are on bushings. So this, for example, is one brass bushing that it's completely free from, let's say, it's not pressed in, it's just a slide on with a good, let's say, semi-interference fit. And the second point is this, which these are instead pressed in bushings, and you can then, if for example one wears out, you can just press it out and press one easily in. Mm-hmm. The same with the upright, it has its own bushing, so when it's time, you just press the old one out and put the new one in. Mm. This is pretty much it. Everything is, let's say, CNC designed and built to spec for the request of the client.
Yeah, aluminum inserts off the wing,
yep,
that we can see already on outside. Yep. And yeah, nice.
We're back.
Giving away a lot more than usually people would do.
It's pretty straightforward, and I like to share, so I think it's something that we need to do more.
Yeah. That's all there is to it. Yeah, thank you, Lapo, for sharing this, giving away all the company secrets.
No, this is nothing.
This is basic, and I mean, if we can improve the automotive environment for better products, then why not? And yeah, hopefully this shows you what we are also capable of for really high-level bespoke projects. Hopefully in the next few weeks and months we'll be able to share.
It depends on the budget, because it's always about the budget.
Exactly, definitely. But we can go even crazier than this. If you want something this for your Civic, when am I getting my Civic DRS for you?
In the winter.
Yeah. It's good. It's a long video, but hope everyone enjoyed. And if you have any questions, ask them below. Lapo maybe we'll find time to answer them. Yeah.